Okay, so we already saw a framework to how to encode an assignment of a three-set formula into a graph such that we have 2 to the n different Hamiltonian cycles, so that the Hamiltonian cycle encodes an assignment, but now we have to put in all the constraints of the formula, right? So the input, again, the reduction we are trying to do, we're given a formula, we have to generate a graph that have a Hamiltonian cycle if and only if the original graph, if and only if the original formula has a satisfying assignment. So let's take our frame graph, and we're going to take enough columns. So we have to take the right number of columns, which if we have clauses, then we have to take 3m plus 1 clauses, vertices along the path. So the path is pretty long. And now the idea is that for every clause in our formula, we are going to assign it 3 columns, right? So this is how it looks like, right? So we're going to have the first vertex is not participating, the last 2 vertices are not participating in this block. So this is why we get 3m plus 1, right? Every block is going to get 3 vertices, which are allocated to it in all the columns. And we're going to now create special vertices for every clause. Okay, and the idea is that we're going to do the same path as before, starting from the top, going down left to right as we want the assignment. And then if we assign it correctly, the idea is that we could detour into the clause, satisfy it, and continue on the trip. Okay, so now the important thing is that in every block we're going to have the rightmost vertices in every block are going to be buffer vertices. Why are those buffer vertices important will become hopefully clear once we do the correctness proof. And now, okay, so now for example, the first row corresponds to x1, right? So when we traverse, corresponding to x1 means that if we travel from left to right, this corresponds to 1 assignment, right? So now in this clause we have x1, right? So we should be able to travel from left to right on this, go up, visit the vertex, go down, and continue on traveling. Okay. Notice the important thing is that the directedness, right? Because if, on the other hand, we come on this side, we cannot go up, right? We have to go forward, and then once we go up, we are trapped. We cannot go up. Okay. So, and we do it now for every variable appearing in the clause, or every literal, where you notice that here 6-2 appears in negation. So we connect, the pattern of connection is reversed, right? If we come on the right, which corresponds to a 0 assignment, we can go up to the clause and go down. So we do this for all the clauses. Right? So we get this graph. This is the graph we get. It has 6 edges for every clause, and that's it. And the claim now is that this graph is Hamiltonian if and only if the original formula is satisfiable. Right now, a priori, this is completely unclear because it's not clear why the one direction, in fact, is easy, right? The fact that satisfying assignment corresponds to Hamiltonian path is pretty easy to see, but the other direction is much harder because it's not clear that the Hamiltonian cycle cannot do bizarre things like leave, go in the middle of a row, go to a clause, then leave out of a different row, travel around, and so on, right? So we want to show that somehow the only way to traverse the row is indeed row by row. You're allowed to do those detours, but once you do a detour, you have to go back to the next row and so on. So Hamiltonian cycle really corresponds to a satisfying assignment, which we will do next.